So next up, we have our first panel focused on privacy research in academia, featuring Cal Bugrara from Northeastern, Emin, founder and CEO of Ava Labs, Sharon Goldberg, founder and CEO of Arwen, and Patrick Mccorry, CEO of Anydot, who will moderate the panel. I'll pass it to you, Pat.
Awesome, thanks for that. I hope everyone's really excited for our panel today. It's going to be about academic privacy, and also it's about the impact of academia on cryptocurrencies in general. But before I begin, what I really want is from my panelists to introduce themselves. You know, our panelists are veterans that have focused on privacy, cryptography, and distributed systems research for the past 20 years. So can these panelists please provide a short overview, you know, on your journey? You know, what got you interested in this research to begin with, you know, 10, 20 years ago? How has it evolved over the years, and how do you see it impacting fintech? Maybe Sharon, do you want to go first?
Okay, so I'm happy to be introduced as a veteran. I got into cybersecurity in 2005 is when I took my first course in cryptography when I was a PhD student at Princeton. And I actually met Goon, I think that year. I don't know if you remember. I was a grad student in the audience of a talk that you gave. I don't know if you remember me. So Goon was already, I think, a tenured professor at that time. So, you know, my story is I started out in infrastructure in telecom. I was working at Bell Canada. I worked at a power company. I went to grad school to study communications. And I took a course in cryptography from Boaz Barak in 2005, and I became obsessed with cryptography. I loved it, and I decided that I had to change my focus for my PhD into cryptography. I was actually an electrical engineering student, PhD student, and because of that, I felt very scared to switch into the theory group at Princeton, which you may know is one of the top theory groups in the world, and that's where cryptography was taught. So I thought I was going to have to find some way to survive making this shift without being like the worst person in the department. And so how I did that was I combined my experience in networking with cryptography. And so at that time, that was kind of like a new way to do things. And I ended up doing my PhD in network security, studying a bunch of things like internet routing security, you know, packet measurement, correctness of communications, things like that. And then, you know, went to BU, became a professor there in around 2010. I've been there since then as tenured professor at BU, working again on infrastructure and network security. And so things that I've worked on include the internet's routing system like BGP. I've worked on DNS, the domain name system, worked on the network time protocol, which is for setting time and infrastructure. I've also worked on a variety of cryptographic protocols. One of my favorite recent projects was the design of a verifiable random function, which we did as part of a DNS project. Actually, we were working on securing the DNS, and that's why we designed this VRF, verifiable random function, VRF. It got picked up by a whole bunch of different communities, actually, and has sort of been taken off in a lot of ways and is now being standardized at the ITF. So that's my story. In 2017, we founded Commonwealth Crypto. And we've been doing a bunch of interesting things around blockchain and infrastructure that I can talk about later on. So go ahead.
Awesome. Goon, do you want to go next?
Yeah. Sure, very happy to. So my story is quite simple, really. I started out in high school wanting to build computers that could be super intelligent, that could do AI type tasks. And but back then that was the late 80s, early 90s. And I quickly realized that the AI technology was nowhere near where it needed to be. Where I thought that that the real problems ahead of us were building reliable computer systems that you could count on, systems that gave you a guarantee and stood behind it. And that was quite challenging back then. And it's been almost 30 years. It's still quite challenging today. So part of building a reliable system is clearly being able to guarantee that it's secure. And so that took me into all sorts of angles. I loved hacking into systems. I loved defending against systems, and I loved building things that are correct by construction. So I was part of the cypherpunks crowd in the 90s. And in early 2000, my very first foray into blockchain technology was when we were looking into peer-to-peer systems. In peer-to-peer systems, you always have people who take more resources, and then you have to have some people who provide resources, but there are very precious few of those. People like to take things and not so much as give things. So my idea back then in 2001 was, well, what if we came up with a magic internet currency that anybody could just have for nothing, but it was still in short supply and nobody was in control of. So kind of like an automated central bank and a limited thing that wasn't easily minted. So I built this system called Karma. I believe it's the first implemented system that has proof of work minting in it. So it predated Bitcoin by 6 years. I published that in the early noughts, and I was counseled by more sort of wiser, older professors to not pursue that research. That a young professor doing that work was essentially committing suicide. And they were right. Back then, we were really concerned about terrorist financing. It was the years after 9/11. So I didn't pursue it, but I pursued a bunch of other things in that adjacent territory in peer-to-peer systems. And then when Bitcoin came along, of course, I looked into correctness of Bitcoin. And my little claim to fame on that front is proving that what Satoshi discovered and what Satoshi claimed was wrong, that his protocol was not resilient. As long as the attackers were a minority, it needed a much bigger majority of honest actors to be protected against attack. Then I worked on a whole range of topics related to coin security and, of course, related to consensus protocols and other cryptocurrencies. That's my short story.
Awesome. I'm going to bring up that 51% assumption later on as well during the panel. Carl, would you like to go next about your background?
Sure. My name is Bugrara. I'm the program director for information systems at Northeastern. My background, originally I was a theoretical computer scientist. I'm second generation Donald Canute. I pursued research in the satisfiability problem and backtrack search. Then I pursued an academic career at the College of Computer Science at Northeastern. Around the late 90s, I got interested in computable contracts. There was a PhD thesis out of Stanford that got into this idea that a contract is nothing more than a bunch of rights and obligations, and you can create some kind of a Petri net of how to execute rights and obligations. Since then, I engaged in deep search of how would you automate, I guess the vision there was that your future legal contract is going to be an app, and engaged in building a platform to be able to automate legal contracts. But I got deeply involved in how to create an underlying infrastructure to support smart contracts. After that, I think I went away from the field for some time, and around about 5 years ago, I was doing some work for JP Morgan, and I ended up a partner to the Quorum team, and that got my interest back into the challenges of the blockchain. And recently I've been involved with the partner outside in the role of decentralized identities in building a new kind of an application infrastructure. And this is what I'm doing right now, is being able to look at the intersection of software engineering, decentralized identity, and trust computing, and the interplay between them to create a different kind of an application framework that would lend itself to colossal scalability.
That's awesome. So I'm going to move on to the next question now. So this is mostly to do with teaching cryptographic techniques and security models. So I remember hearing this joke a while ago that Dan Benet, who's a famed cryptographer at Stanford Universities, he loves cryptocurrencies mostly because it piques the interest of his talented students to go study cryptography. So he uses this like a carrot to get them to go do something else. I'd like to hear your experience, everyone here, as teachers, tutors, and mentors. As cryptocurrencies help pique the interest of your students, have you leveraged that to, bring them in a different direction towards more general cybersecurity research or smart contract research, et cetera, et cetera. Maybe Carl, do you want to start with that question?
Yes, yeah. Despite my theoretical background with years being spent in the corporate world, when I got back to academia, it was much easier for me to articulate these theoretical problems from a social perspective. We got into the voting problem. We got into protecting the drug supply chain problem. We got into medical credentialing problems. We got in the settlement process and stocks. These became very powerful. I always find these kinds of problems to be very powerful motivators for students to dig deeper into cryptography. So this is very different from my upbringing, where number theory was step number one to cryptography, to using social complex challenges as a starting point for having my students dig deeper into cryptography. And I found that amazing motivator. Little I had to do versus the traditional approach that we usually followed in academia. And I think one of the simplest things we had to do early on was in relation to HIPAA, where the minimum necessary requirement in HIPAA for patient data, we ended up figuring out a way where we give control of the data to the patient and provide a smartphone capability to allow the patient to consent to whatever doctors wanted to build. That was an amazing challenge to students, where Kirpios was a big part of solving that problem. Right? Before we discovered the role of the blockchain as a powerful mechanism for creating a new cryptographic platform that's more standardized than having to put these cryptographic techniques and applications ourselves.
Pretty cool. And Sharon, what about yourself? I know one of your students, Ethan, who's also like an amazing blockchain researcher. I guess he came to your office one day.
Well, so I have a lot of different answers to this question. I'll tell you a story from 2011 or 2010. I actually, in contrast to Goon, I did not come from the cypherpunk world. I actually was like a telecom engineer, and then I got into cryptography when I was around 25. So I didn't come from that world, and I wasn't hacking when I was a teenager or anything like that. But what happened to me when I got to BU, right when I was a young professor, I would frequently have students show up at the door of my office, and they'd be like, "Did you hear about this hack? Did you hear about this like attack? I read it on like Reddit. Did you see this blog post?" And I never saw it. I had no idea what they were talking about, right? And that was like kind of before I was on Twitter and before I was just tracking everything all the time the way I do now. And so I was sitting there and I'm like, I'm the professor. What am I going to do? I look like a fool. Like I'm hearing it secondhand from my students, right? So I figured, first of all, I have to stop hearing things secondhand from my students. And second, that there's clearly something going on here where my students are like showing up at my door. Like I remember like one of them running in and like stopping, "Did you hear about this?" And I'm like, "Yes, what was it?" And they told me about it. So, what I realized is like, this is what I feel like, and I continue to see this through my career in the last 10 years as a professor, is that this is a lot of the reason that students get interested in this stuff. It's just in the news all the time. Whereas 10 years ago, it used to be in Reddit threads, or if you were on Twitter in 2010, maybe you would have seen it, wherever it is that people were seeing things back then. If you fast forward to like 2015, you would have seen it in the New York Times and the Washington Post and in the mainstream media and everywhere. And now it's everywhere constantly, right? And so I just feel like cybersecurity issues are such a huge issue in the world now, and students are just constantly aware of that. And that to me is driving a lot of them to pay attention to the field. I will say that for myself, one of the things I did to deal with my students' interest in these topics and to make sure I always knew what was going on is that in my class I have had for years a project where you have to basically analyze a security incident that's been in the news and go into the technical detail, explain what really happened, present it to the class, do a presentation on the legal and ethical issues. And I still do that. I'm doing that this year in the class that I'm teaching that I taught this morning. And so that's been one of the things that I feel like has constantly pulled them in. I will tell you for myself, I don't remember what year was this, maybe others do, but I remember seeing the State of the Union address, and it was Obama was the president at the time. And he was saying like network security is a priority for the nation. And I was like, oh my God, this was very early. I was very surprised because that was my area, you know, and I never thought that I would hear the president talk about it. So I think that there's a lot of pull, and I definitely think that cryptocurrency is a really big pull for cryptography, because you see a lot of advanced cryptography that gets used in cryptocurrency that doesn't often get used in other industries. And actually, I think what's now going to happen is that other industries are going to start pulling in the technology that the cryptocurrency community has developed, and I'm already seeing that now. But I will think for students that the pull has been, you know, from many different directions to get into this field and this type of thinking, because it's such a societal, it's of such societal importance that they're being bombarded by it, essentially, if you follow the tech news and even the non-tech news.
So I guess we're also talking about the TikTok fiasco now as well. Goon, do you want to go next? I mean, because I just at highlight, I mean, Cornell has probably the biggest blockchain group in the world. You have like an army of students. So what's your experience been like? Obviously, it's been very good.
You're on mute.
I can't hear you, Goon.
Goon, you're on mute.
I'm muted, sorry. Yeah, let me add to what Sharon said. I have a couple of different vantage points. I talk to different kinds of students at different stages of their educational career. And, you know, when I talk to high schoolers, I usually start by asking, how many of you have ever sent a secret message, a secret note during class? How many of you have had the secret note confiscated by your teachers? And you should see the number of hands that go up. And then you say, well, look, let me show you a way where if the teacher takes the note, you know, he or she will not be able to decode what's going on. And all the ears perk up. So there's something magical about being able to connect with kids at that age. As they get older and they get more sophisticated, then you can actually bring in a bit more, slightly heavier math. But it turns out a lot of the core concepts in cryptography are actually accessible to someone with a basic high school, you know, early high school math courses. When we get to the undergrad level, I found that when I talk to non-computer science audiences, one of the biggest draws is the criticality of cybersecurity. That really gets them excited. You know, oh, what if somebody could hack into the national grid, the electricity grid? What if this, what if that? That of course gets everybody's attention. This stuff is critical infrastructure. And also the amount of money, the amount of value tied up. You tell them, look, the biggest heist in world history was $38 million. And but just 2 years ago or 3 years ago, I was involved in trying to recover after a $55 million attack that somebody launched on Ethereum. And so now you tell them about that 55 million heist that somebody launched from their den, probably. They were just sitting in their room and kind of went and took 55M. So that gets people excited. And of course, at the graduate student level, one of the things that draws people to this area is the difficulty of problems that are buried underneath these systems. The consensus problem in distributed systems is absolutely monumental and very difficult to solve. It sounds very simple. I could describe it to any audience within 30 seconds, and yet the solution space is really big, and none of the solutions, at least until recently, were any good. So that gets people excited. And in fact, one of my pet peeves is actually, despite the name cryptocurrency, most of the difficult problems, I would say, are actually on the distributed systems side. They're not on the cryptography side, and at least from my vantage point. And then I try to pull students into distributed systems through by discussing these advanced topics. And then final thing, of course, the communities around these systems are really big and interesting. They somehow, the moment value is involved, people get very heated, and they become it becomes almost like having a soccer team that you are a big fan of, and so suddenly people that you don't expect have very strong opinions on distributed systems topics, and it's really a sight to see. So my job, though, in dealing with all this, I see it as trying to pull people away from the brink of what I would call the trading abyss. So a big problem scenario that I see is people get into these areas, but they develop only a superficial understanding of the technology, and they just want to make money by trading tokens whose function they don't understand. So that I try to avoid, and I try to channel them back towards technical issues.
Yeah, just like the recent rise of the food tokens where they don't actually do anything, but it's just coin go up economics. Okay, I'm going to move on to the importance of academic papers. So I know when I started back in 2013, there was this ongoing joke in the cryptocurrency community that academia was catching up for research. But I want to sort of, put that meme into perspective, because around that time, it was really academic research that demonstrated that Bitcoin was not anonymous whatsoever. We just seen that in the previous talk. Um, and in fact, with Goon, I mean, Bitcoin's the most traceable currency in the world, so it's not anonymous at all. And as Goon mentioned earlier, some of his work in Southeast mining demonstrated that the 51% assumption, honest mining, is not good enough to keep, Bitcoin or other cryptocurrencies safe. So what I want to ask is, how do you think academic research has impacted the field? Do you think it's being taken more seriously compared to other research domains in cybersecurity? Goon, do you want to take it from there?
Sure. Just to add some color to that story, when we came out with this finding that what Satoshi said was wrong, we were faced with a barrage of attacks, from the personal to the incredibly personal to all the way to death threats. So, and it was really funny that the community, the research, the practitioner community didn't believe us, and they decided to crowdfund a simulator to replicate our results and show us wrong. And of course, everybody who ever built a simulator, verified what we said. And ultimately, everybody's opinions had to change because science has this way of, winning hearts and minds. You can deny it, but, it's there for you. And so, the people went from hating me and sending all sorts of threats to me to suddenly having to invite me to conferences and saying, hey, we have another problem. Could you look into that? So that was that transition. And I think, so then what happened? Well, I think today we have a very healthy academic community. I know I worked hard to get my colleagues interested. I worked hard to go to my adjacent areas and get my colleagues in programming languages and other topics interested in looking at smart contract verification, for example, a topic that deserves a lot of attention. And so now I think we have a burgeoning academic community that's fairly strong. I'm beginning to see sort of the latecomers in academics come into some of the areas. So, as with anything, there are the early movers, and then by the end, you've got people who are really polishing, what we call slicing the salami really, really thin, who are just, coming up and trying to define or identify really, really small problems and blow them up into big things that, in reality don't actually matter. So there's a lot of work that's coming in that's late to the scene, that I think is now kind of, they're trying to avoid a worst case scenario that never happens, for example. That's a very common trend in academia. So there's a lot of low value academic work that I think we're beginning to see. We're beginning to see, of course, an explosion in the number of blockchain papers, most of which I think bring only marginal value. But nevertheless, that's just sort of natural progression of things. We're also at the same time seeing enormous sums of money being poured into projects that I would consider, and most academics would consider, are at the level of a master's project. They don't really advance the field at all, or maybe advance the field in some tiny fashion, but nevertheless, the crypto community thinks these are really great ideas. There's enough Greek letters in the white paper, and then here's another 100 million given to a project that clearly has absolutely zero use cases and no path forward. So we're at a funny time, and I'm not sure how it's going to pan out from here. I think I would like to see the big problems in cryptocurrencies addressed by academics. I would like to see the practitioners not become pretend academics. There's a lot of pretend academics among practitioners. They sort of adopt the accoutrements of science without adopting the scientific method. At the core of the scientific method lies the ability to be wrong. And if you've got a set of people who are so firmly entrenched in their system that they cannot be proven wrong, then that's not actually science. We're seeing a lot of that stuff. So we'll see how it pans out. There's money and value involved, so I don't really have high hopes. There's going to be a lot of junk science on both the academic side and the practitioner side. And it's up to all of us to identify what's valid and what's just sort of, makeup on the pig.
Awesome. And I actually want to ask Sharon two questions. So the first one is going to be sort of cryptocurrency related in the sense that Sharon has a background in network security. And one of your first big papers in the cryptocurrency space was you and your student, Ethan. You looked at Bitcoin, you're like, oh, the network security is bad. And you done an Eclipse attack where you could, isolate a node and make them look at the wrong blockchain and then, potentially do very bad things to them, then that's based on your network security background. Do you want to give some comments on that and how the community took that?
Yeah, so I want to react also to what Goon said. I think that it is it's sort of like there's no words to describe what's going on right now. I think in academia, I think it is because, coming as an academic, and looking at, in 2017, looking at some of the work that was out there, I was totally baffled by some of the designs that I saw. Like they just didn't make any sense to me. They would not, Goon was being generous by saying it's like a master's project. We saw a lot of that stuff happen and get a lot of attention, actually. We also saw amazing things being done because you basically have people with no inhibitions, no concern for like, how complex is it, this thing that I just built? Like, why don't we just do it? Throw in the kitchen sink and let's see what happens. So on one hand, you get these like really fascinating experiments in technology that get really worked out to an extreme where like I've never really seen something like that before. So it was sort of fascinating where you would see almost like very, very untrained people pulling off these incredible things. So there's sort of like two sides to the coin where you would see things that are completely like looks like gibberish to you, but then you actually, and maybe it is because the paper looks like gibberish, but then you actually go and it's been built and it's coded and you can go look at the code and you can figure out what it does and maybe it actually does something cool. So it is a bit of a magical period in terms of inventions and things that are happening, both in academia and in the industry. I would say for myself, one of the papers that I did with Ethan, who's my co-founder and also formerly my PhD student, was looking at network attacks on Bitcoin. This was very early, I guess it was 2015, early-ish, where we were like reverse engineering Bitcoin's networking, peer-to-peer networking protocol. This was not really written down anywhere. So in order to actually even know what it was, we had to like reverse engineer the code, like read the code itself, put in a bunch of statements and try to figure out what it was doing. And then we found a bunch of attacks that were then patched through various patches that we had thought of and that we had developed. So, that was like an example of us coming in as academics and actually going right in and getting code deployed in Bitcoin Core, as like code that was written by Ethan got deployed in Bitcoin Core. So there's been just a lot of different things that are happening that you wouldn't expect. I want to bring up one thing that I personally am like a huge fan of, and that is threshold signatures or key splitting. And I will tell you that the blockchain community is way ahead in terms of credential storage. If you look at credential storage in sort of traditional cloud cybersecurity products, it's very common that you'll use what is basically like a certificate authority model. So if you're familiar with the way that TLS on the internet works, when you visit a web page, that web page has a certificate. So if you're trying to visit Google, you'll get the certificate for Google. Where does that certificate come from? It comes from a certificate authority that issues it. And that certificate authority has basically broad latitude to issue certificates for whoever it wants. And so what that means is if the certificate authority is hacked, all is lost. All security is lost because it's just a sort of trusted party that's completely trusted. Now, in the blockchain world, we've learned that putting all our keys in one place or putting our eggs in one basket is a terrible idea because things are constantly getting hacked. The attackers are going to go after that particular trusted party as a point of attack, as a honeypot, and steal the credentials from there, right? And so in the blockchain world, you'll typically find things like key splitting. There are plenty of companies that have used what was initially academic research to take eCDSA keys, break them up in two pieces, and put one piece, on the user's phone and the other piece in the cloud. And now you can actually, use this key, but you don't have it sitting in one single place. So in order to actually hack, you need to hack into the user's phone and the cloud, which is really hard because they're two completely separate systems, right? So this type of technology, which is now basically standard in the blockchain world, it really doesn't exist outside of the blockchain world. And I think that that's one really cool thing where you see blockchain industry being a very early adopter of cryptographic innovations, but I do believe that these innovations are going to be then dispersed into more industries after the fact as well. Once the cryptocurrency industry and the blockchain industry proves that this can be built into working systems, you're going to see it migrate to other systems as well.
Awesome. That sort of brings me right into my next question. You partially answered it, but I'll ask it anyway. So as we all know, cryptocurrencies and smart contracts represent the largest bug bounties in the world. You have a program that's 40 lines of code on the network. If there's one bug, you could lose millions of dollars, and there's plenty of smart contract hacks examples there. You know, Goon's very familiar with the DAO hack, which was this Kickstarter program, and this black hat hacker managed to, you know, exploit a bug and drain. I actually forget how much was drained now, like 20% of all ETH. Some of them, you know, some of the large magnitude anyway, and then they had to revert and hard fork the network to fix that. But actually, I used to make this joke as well that there's these high profile thefts and hack every 2 to 3 weeks in the cryptocurrency world. And frankly, that's also quite true. There is basically a hack like every 2 or 3 weeks, is the more interesting than Coronation Street. But, you know, where are the thefts though, and how are the hacks performed? I give the smart contract example, but actually a lot of the hacks, the really big thefts, had nothing to do with the blockchain and had nothing to do with the smart contracts. The classic example is Mt. Gox. They lost 800,000 Bitcoin back in 2014, which today's obviously a ridiculous amount of a couple of $1 billion worth of Bitcoin. And the way they got hacked was back in 2011, 2012, someone hacked their server, they stole the wallet, they copy and pasted it, and every once in a while, they'd just turn on the wallet. If it had Bitcoin, they just sent it to themselves. And Mt. Gox had no internal auditing. They realized that they even got hacked. The other big example was Bitfinex. They lost 120,000 Bitcoin. Someone hacked their server. They basically stole the Bitfinex had this setup where it was a 2 or 3 multi-sig. So Bitfinex had to sign it, BitGo had to sign it, and then you get authorized and sent out. Someone hacked Bitfinex. They basically stole the API key for BitGo. They took a chance. They sent the transaction to BitGo, they countersign it, and they returned back and they just signed it, and they stole 120,000 Bitcoin. It was later commented that Bitfinex had a special or BitGo had a special configuration with Bitfinex. Take that as you will. But these aren't really cryptocurrency problems. You know, these are server infrastructure, cybersecurity problems. You know, and most cryptocurrency companies could actually learn lessons from, you know, the very traditional industry of how to keep your server safe, which is basically what Sharon was talking about. So I'm just going to ask it anyway, Sharon, you know, based on your 20 years history of cybersecurity, are you aware of similar examples of thefts as in traditional fintech? Maybe, you know, what can be done about this? How can people build more secure server infrastructure so they just don't easily get hacked? Oh, you're muted.
So to step back from that question, I think the cryptocurrency industry is, again, it's a proving ground for cybersecurity in so many ways. There's very few things in the world that are as small and stupid as a Bitcoin key, but worth as much money, right? So like a Bitcoin key is like how many bits? I don't remember right now. I'm really sorry, my brain's not working, but it's a small number of bits, and 512, sorry. And if you lose it, you lose like potentially millions of dollars, right? And so it's very easy to exfiltrate 512 bits from somewhere if you want to, if that's your objective. And so I think the cryptocurrency industry has been forced to secure things to an extreme, I think, beyond what you've seen in other industries. And one of the dirty secrets in the industry that any engineer will tell you is that you can put your keys in an HSM, right? So HSM means hardware security module. So you can put your keys in a unhackable hardware token, hardware module that would then be called, you know, to make, you know, signatures for Bitcoin transactions and things like that. And this module where the key is inside is like really secure, and like nobody's going to be able to get into that unless they can, like, you know, parachute into Amazon's data center, like break into the server room that has the HSMs and like steal the HSM and then like rip it open with some pliers without breaking everything and exfiltrate the key, like really unlikely kinds of attacks, right? But if there's a key in there and you're actually asking for signatures, there's some code that's allowed to interact with this HSM. And so the dirty secret is that once you get into the cloud, you can maybe get access. Maybe you can't steal the keys, but maybe you can produce signatures on things that you shouldn't be able to, and now you can move Bitcoin. Another example, if you have two companies that are working on a collaborative product, how are they connected? Via an API. How are they authenticating themselves to actually like run code from one company to another? How is that happening? That's usually authenticated through an API key. What happens if your API key is stolen, right? And so And that's exactly the example, one of the earlier examples that you gave, Patty, about like a theft of an API key resulting in actual theft of Bitcoin, right? So I think one super fascinating thing that in the cybersecurity industry is of great importance is the protection of secrets, protection of API keys, protection of servers. Who's logged into your servers? What are they doing? What secrets do they have access to? There's a whole industry, a huge industry built around the protection of credentials. And I think the blockchain industry is actually really interesting as a place where you really, really need this stuff, because if you mess up, then millions of dollars get stolen. And so I think that this industry from a tech perspective is just an amazing proving ground for cybersecurity innovations, because if you don't do it, you'll get hacked and then you're embarrassed. So you have to do it, right? And people will try to steal those keys.
Yeah, Patrick, just to follow up there for a second, looking at it, our experience coming at it with what would be new innovative software engineering techniques that will allow us to build better applications for the future. No matter how much we encrypt, no matter how much we do to secure our APIs, we still have these applications to be built and secured. And moving away from traditional software engineering techniques to a new way of thinking what an application is really necessary for building privacy. We went from a model where we were talking about the machine human interface model to that the application is really a reflection of us. So being able, the work we're doing right now is, can we decouple the identity out of the application completely and use the blockchain to create a decentralized identity with the blockchain as its root? Will that allow us to give us more effective design techniques to allow us to build applications to scale? And being able to think, because now, you look at an application, it's really us, it's a social structure. And being able to think in terms of privacy from identity is going to be very key in delivering a new kind of privacy in the future.
Let me add one additional thing to this discussion, and that has to do with the following, I think, social phenomena. For, I would say, at least the first 6, 7, 8 years of cryptocurrency community building systems, what people did was they took a very compartmentalized view of security. I secure the blockchain, I leave the key management to you. I secure this component, I leave the rest to you and to external components. And so if you look at an exchange, for example, the correctness of an exchange depends on the correctness of the underlying operating system, underlying database, underlying app framework, and underlying app that manages the entirety of the exchange. That's enormous amounts of code. And I guarantee you that there isn't a single software stack that is up to the task. You cannot build a secure exchange today. If you look at the wallet, where is this wallet? Well, a wallet is on a phone. Well, how secure is my phone? Well, it's about as secure as my practices. And, I will download a flashlight app from some random guy in Germany without a thought. And then suddenly it will break out of the jail and it will be able to capture my keys. And we saw that happen so often that the cryptocurrency community coined the phrase, "sorry for your loss" became an acronym. So it's very common for somebody to say, "I lost $1 million," and somebody just says SFYL. It's just short for "sorry for your loss." You don't even have to spell it out because you couldn't spell it out enough many times in a day. These steps happen all the time. But I think this attitude has to change. My group worked on this notion of vaults for cryptocurrencies. And I know now that we are actually seeing them deployed in a lot of commercial settings. And we're going to see similar ideas where the currency system itself is tasked with building something that could be secured even in the absence of a secure underlying platform. Even if the OS is compromised, even if the exchange is compromised, there are measures you can take. For smart contracts, again, my group suggested the notion of escape hatches and crowdsourced escape hatches. So it's even possible to have decentralized versions of security measures that can allow the underlying system to operate in a secure fashion, even when the accoutrement technologies are not to be trusted. So we're going to see ideas like this come to the fore. I think we're going to see a change in people's attitude, or we should see a change in people's attitudes. There is still, I think, your standard, whatever, regularly educated cryptocurrency developer still today has a very, very narrow view of their task. And that has to change. They have to say, well, look, even I know that these other things that I rely on are not secure. I still have to do something. I still have to provide the guarantee to my users.
Awesome. I'm just gonna, I guess we're basically out of time now as well. I should highlight that. I just wanted to add one final point. I remember back in 2013 with the Android wallets, Android had an insecure random number generator, and that was detectable on the blockchain, and people just had their coins stolen randomly because people could, predict what their private key was. So if everyone has like last, I don't know, 20, 30-second closing statement, maybe that's a good way to finish off the panel. Sharon, do you want to go first?
Yeah, I guess this is just what's at top of mind following what Goon said, which I really agree. I think one of the innovations that blockchain has brought and will bring into other industries is this concept of like your certain component will be compromised. What are you going to do about it, right? So you cannot secure things to the point where nothing can ever be compromised. And so the way you want to build systems is in a way that you really have to go and attack lots of different parts of the system at the same time before you can actually compromise something. And so that's why I brought up this idea of key splitting, which is a beautiful concept, right? Where you can't compromise like a single server. You'd have to compromise 2 servers on different cloud providers, or maybe a server on a cloud provider and then something on your phone, or maybe something in your browser. But they're all different, and this diversity of systems actually makes it very hard to do these types of attacks. And so I think, to wrap up, I think, that there's a lot of like extremely advanced technology that's coming out now in the last few years, partially due to sort of people's lack of inhibition in designing like crazy things and just launching them, and they have millions of dollars and they can do it, but also just in the extreme nature of like how difficult it is to actually protect 512 bits that's worth like $1 million or multiple millions of dollars. And it's really leading to broad amounts of innovation that will be, all over cybersecurity, I believe, in the next 10 years. Outside of blockchain too.
Do you want to go next?
Sure. So let me just very quickly mention a couple of ranty ideas and leave the audience with those. So first of all, if you go look at the number of cryptocurrencies out there, you will notice immediately that there is something around, I think it was 6,000 when I last looked, maybe it's 8,000. So there are about 8,000 of these systems. All of them are converging to the same narratives. All of them, no matter how crappy they might be, are saying the same things. So you have people who are running essentially centralized systems. You have people who are running known broken systems. Everybody knows that they're broken. We just don't bother to fight it out with the people who bought into that system. But everybody knows that they're broken, and yet they're out there and they're saying very much the same things about their system that Sharon might be saying about hers, or I might be saying about mine. So this convergence is really stemming from people's inability to actually pave a new path. They just copy what they saw and they just add they dress it up with words. And what you have to do in evaluating these systems is look under the covers, look for true innovation, look for a new vision. Just copying yesterday's technology with a little bit of dress up is not going to cut it. And don't be the boomer in the room that's buying into technology that's new to you, but really 10 years old. So let me just caution you, for example, that there's a lot of narratives out there that pits cryptocurrencies against fiat. They will tell you that, hey, we're going to go through an inflationary period, and we will, because the Fed said we will. And so therefore you should buy into digital gold, here is Bitcoin, etc. These are fine narratives, but there is much more to this technology than competing with fiat. In fact, the greatest value, in my opinion, lies elsewhere. It lies in digital assets that are tradable across the globe, and not necessarily in money that competes against sovereign issued fiat currencies. So there is a big universe out there, and I suggest that everybody does their homework, does their research, and looks into systems that are truly innovating and going in areas where others are not. Everybody and their brother wants to be money. And that's a tough game to play. And I don't know that that's a winnable game. Power to anybody who wants to win it. But the real innovation, the real value to be created, I believe, in my opinion, that it's elsewhere. And that's what I'm doing at my company. And I know there are a couple of other worthy competitors, but that we are very few and far and few in between. And I would like to see more competition for me, as opposed to the current state of affairs where everybody is just converging towards the same boring narratives of 10 years ago and unable to move forward, and just copying each other's code, copying each other's ideas.
Awesome. And Carl, do you want to give a quick 30-second closing statement?
Okay. Yeah, so I think my passion is going to continue to be around the impact of blockchain technology and coming up with the new software engineering techniques that will make it easy for us to build applications of amazing scale. And I see that happening every day in the type of techniques that we are building. And hopefully the impact of blockchain on computable contracts is going to be a huge endeavor as well, moving to the future.
Awesome. Thank you everyone for joining our panel. I'm sure everyone enjoyed listening to it. I can't see anyone, but yeah.